This is the actual measured reality of the meter. Then you may ask, what are these two? So when you go to this page, you can write so many, you can key in so many parameters. What is the length of the wire? What is the diameter of the wire? Because sometimes you go to a substation yard, your PT may be here, and the wire can go up, down, to come to the control station. The wire can be quite long. So you need to consider all those factors sometimes.
Mua đi control đúng là mua đi ngân hàng chạy chấm tương cá nhưng mà chặt rộng hai bên là đây storm sai này vì control được không này đây đây lại đây storm sai bộ mùi nên lại VA con burden con return á cứ bộ rộng thôi thế vì là tiêm soát mùi này burden con VA.
So actually you can key in what is the approximate length of the cable, what is the diameter of the cable, etc. So this is the actual S, beta 1 is actual measurement. This will be higher than that because this takes this plus the loss in the copper, everything. It will calculate based on the length of the wire, everything. Okay. So that is why all these are manual. Okay. It is all written in the manual. But in the field, I will most likely look into this. But if this value is too high, then I worry about it. But this value is meaningless if you don't enter this value. You have to manually key in the value. Okay, what is the, because your plan and drawing will know how much length cable, what is the diameter of the cable used, etc. If you don't key in the value, this value is useless. But this value is still valid. Okay? Okay? So this is all about measuring the power consumption of the meter. Why power consumption of the meter is important and the length of the cable, everything, because that is the load to the PT. Yeah. Okay, similarly you can do CT. CT is more simple to understand. Okay. So what is CT? Basically what can contribute to the CT? It is your connection wiring. Maybe loose contact. It is not crimped properly. Your wire diameter is smaller. Okay. So always the lower the burden, the better, right? The thicker the cable, the least resistance is the best for CT. Okay. So for CT, the lowest resistance is the best. Dead short is the best for CT. So if your CT, the burden is high, the accuracy of the CT will also come low. Okay, so all this is important because the people, I've been working in this field for more than 30 years. I know people cheat. Sometimes cheat, sometimes by mistake. Some people are very smart, they don't do full cheating, partial cheating, so that you never get caught. But you still save energy, save money. So some people use thinner wire. I know customers, maybe they use 3 or 4 wires in parallel when you install, but later cut off some wires. So the diameter comes low. So your burden is high. Then your CT is less accurate. Understand? So this is for CT burden measurement. So this is very simple. Okay, for CT measurement it is a bit tricky because how do you measure CT? You basically pass the current through the current terminal of the meter and measure the voltage across that. Okay, so it is basically your resistance of the wire most of the time. Why this is very tricky? Because you go to the customer may not have enough load at that time. So it is very difficult to do this test in the field when the customer load is too small. very, very small. Maybe he just put one lamp or something, or when the customer is not at home or customer plant is shut down, yeah, then it's very difficult. You need some current, right? You need some current because the resistance is so low already, maybe in few ohms, it is all millivolt or microvolt. So you need some decent current through the wire. Okay? That is why, if you remember, earlier the first presentation I showed today, you saw 20 millivolt to 300 volt. You may ask why you need 20 millivolt in power industry. Only for this reason. Because only in channel A, that means phase 1 voltage, that channel alone can measure very low millivolt like in a multimeter. Because you are talking about checking the wire resistance by passing a current through it. Okay? So that is CT burden measurement. Then another case of you have a PT ratio measurement. So you have two set of clamp. You connect one clamp to the primary and one clamp to the secondary. Okay? Of course, you did not buy the PT side. Okay, you did not buy, but later you can buy something like this and use it. So this can be of high voltage. High voltage. Sometimes this voltage is not high rating. You may need to put a hot stick and connect. Okay, so this is very easy. You can test live what is the ratio. Okay, so remember one thing. This is only a ratio measurement. This is different from fully testing the CTOPT. For fully, this instrument cannot test the full CTOPT because CTOPT has many other functions also, many other parameters. But this is a very quick check because all the other tests, suppose you use a ohmmetron or such instrument to test, you need to literally you need to shut off everything, you need to disconnect and then only you can test. But this, in real life, on load without shutdown, you can do. Okay? So you roughly know, immediately you know the ratio on the screen. Okay? Same with CT ratio also. You take two set of clamps. Okay? So maybe on the maybe on the LV side, if you have a high current CT, you use this and one primary, maybe this maybe our other way around. Okay? And you can straight away measure the accuracy. But these CTs are not good for medium voltage, for a low voltage. For medium voltage, your isolation is very important. So you may need to use hot stick. Okay?
Why this diagram? Why this diagram here? You need to scroll down, not directly here.
Good question. In this diagram, it is using these wires, not a clamp. It is going through the meter and coming back. Because it is a CT secondary, so it is 5 amps.
So we need to.
Okay, you asked a good question. Okay, let me explain to you that. Okay, how many ways you can measure the current? I told you earlier, we can measure current through this. No need of CT. You can, but this maximum limit is 12 amps.
Yes.
Okay? This is more accurate than this. Clamp always not so accurate like this. Because clamp, after some time, dirt falls in, and if you don't maintain it properly, it will lose accuracy. You have to really maintain it very well. So this is always more accurate than this. So in this picture, just now, it showed, basically, it is going to the instrument.
In this case, if the actual instrument, we have to touch down the power.
Not necessary. That is why you have a test terminal block. You have a test terminal block. You connect it and open the link. So you initially you short the link, you connect the instrument and then you open the link. Okay, then it is safe. If you don't want to touch the test terminal blocks, of course, then you use a clamp. The advantage of directly measuring it is more accurate. You taking through it is definitely more accurate. Okay, then you have no choice.
Yes. You do that. Nó về con với hai về lọt từ xa nhưng không bê tô để quạt thở ní cứ quạt chặt quạt tông xong rồi đấy nó này quạt trở đón nước này Kennedy sai nhé phân CT nhé rồi đấy nước không sinh nó mỏng như thế này từ xa ấy của con đi là ca stung bằng kết kia bình thường nó lọt muối để bây giờ switch bài thẳng do thang được về để quạt trong chạy bờ lên con ratio con CT đó cứ quạt bài thang trong này mò không thôi để làm bay mò tay cái lời thì có mót quạt sưu nó trâu mò không tên ở đây mà sáng chạy sáng không nhớ cứ tăng đến cứ chỉ học như là lọt năng đi cứ trên vì CT mất cứ để cho công tơ một chắc cứ học đi thì nó cứ thờ plan là mình hiến plan muối chặt nơi này ở primary cái plan muối chặt nơi này secondary bởi vì mặt thời gian tế bởi vì thời tam là là quát cứ dân từ đánh từ này người ta chạy đánh dân từ qua hành đưa lại lại liền mà cứ dân qua riêng hàng một chạy dân thở cứ dân qua toàn nhấn trong bách cái thở plan này người ta trong buổi phân quát ấy chứ có thở plan cứ để xa con mấy nạt thân nó lỏng để ai đặt hàng để cho nó liên để nó bán hay còn nó quạt chặt cho nó cho được phân sinh để lại của ấy được không một sinh ấy đi quạt vậy số 4 cứ mình trong bạch ở viên vị thi sáng để quạt cho mang khi vị thí cứ thì muối cứ quạt để cho không đơn mà nhưng sáng còn cho không đơn mà người ta pe với ban phần là đọc phim pe tự sinh bờ cho đoạn lớn đó cứ những thời ca làm bị chặn như đây này thì những trong buổi này quạt chi ọt bờ class người ta chi cắt thôi accuracy con viên ở căn kia này tự sinh bởi những ở class nhưng đang class cứ viên accuracy con viên mùi viên error viên mùi điện chứ bởi sinh viên ở class to mà tăng hết những error con này class nó buộc người error còn sinh thì ai chưa ở qua phải những error của chi mùi điện cái bạn trong buổi này cứ quạt chặt cho để tại bởi thân thì những ẩm thì lớn tết như thời lập thờ class mới chặt
Okay. In the old days, the meters, electromechanical, they sometimes consume more power. Now the smart meters, some of them don't consume so much power. So sometimes using a very high rating CT and PT also not so good. Because suppose let us say your application, your meter is only 2 VA or 1 VA. You use a 30 VA or a 50 VA CT or PT. Not, it is technically correct, but maybe it is better you are spending too much money for nothing. You don't need such high power CT or PT. Okay, you can use much lower. Because the reason is, even if you use a very big CT or PT, at low current its accuracy is not as good, very good.
I know you cannot mention about the minimum and the maximum of
yeah, correct. So all CT and PT at low current it is not accurate. So if you use a very high CT and PTR, then also if your actual consumption is very low, it is not so accurate. So the point is, you test the meter alone for EDC is not good enough. You need to, your aim is to have to ensure that the EDC suffer less loss. That is all your aim. Okay. So not only meter, the error can be contributed to the CT or the PT and the choice of CT and PT also. Sometimes okay, the CT is wrong. So what happens? Okay, they go and check in the store. Okay, I have only a very big CT or PT. Okay, put it that time. Then later forget it. Then that will stay there for like 10 years also. Never know. So sometimes it is important to understand this. It is good to be optimal, not too much out.
I have one question about want to check the electric burden of the CT. How can I do it?
This cannot do it.
Because
Yeah, this is testing only the load to the CT. If you want to actually test the CT, you have to use the CT analyzer, like what Omicron and all this.
when I check in the Omicron, the diagram is like this one. It's with the merger the CT burden of the load, not the real burden, not the electric burden of the CT.
It can measure. I don't know which equipment you use. It can measure.
Because sometimes I'm afraid that our specification for the CT is, for example, 15 VA, but actually maybe the supply is lower than this. I don't know. Yeah.
But you can, if you use most of the CT analyzers,